Hello and welcome to lesson 2P. I can determine what theorem or postulate I should use to prove either angles to be congruent or lines to be parallel. Well, last lesson we proved 8 different theorems on how to prove angles congruent given parallel lines, or how to prove lines congruent given either congruent angles or supplementary angles. So what I want us to do today is basically to summarize when you can use each of these tools. So let's take a look at this first guy. If I'm given angle 1 is congruent to angle 5, and I want to prove line A parallel to line B, there is a specific theorem I could use to help me do that effectively and quickly. And that theorem is the alternate exterior angle theorem. We know it's the alternate exterior angle theorem because those are alternate exterior angles, and we proved last time that if alternate exterior angles are congruent, then my lines are parallel. So number 2, if I'm given C parallel to D, so if I'm given that these lines are parallel, what theorem would I use to prove that angle 5 is supplementary to angle 12? Well, when I'm looking at that, I can see that 5 and 12 are consecutive interior angles. And if I'm proving angles to be supplementary, then I'm going to use the converse theorem. So I use the converse of the consecutive interior angles theorem. Interior angle theorem. There we go. All right. So let's look at this next one. They give me angle 2 is supplementary to angle 15. Well, angle 2 supplementary to angle 15. Those are consecutive exterior angles, and they want me to prove that A is parallel to B. Now, real quick, folks, A cannot be parallel to B. That's a mistake, right? Because if these two are consecutive, that's going to prove C parallel to D. So I want you guys to scrub out A parallel to B and instead write C parallel to D. And those are parallel by the consecutive exterior angle theorem. Now, why am I not putting the word converse in front of that? Well, I'm not using the word converse because we only use the converses to prove angles to be either supplementary or congruent. We use the regular version to prove lines to be parallel. So let's take a look at number 4. Number 4, they give me that angle 10 is congruent to angle 12. Well, here's angle 10, here's angle 12. Looking at those are corresponding angles. And if those corresponding angles are congruent, then I'll be able to prove line A is parallel to line B. And I'm able to prove that by the corresponding angle postulate. Now, in this next problem, I'm given that A is parallel to B, so A is parallel to B, and I want to prove that 11 is congruent to 15. Well, here's angle 11 and here is 15. Those are alternate interior angles, so I'm going to prove that those are congruent by the converse, and again I'm using converse because I'm proving angles congruent, of the alternate interior angle theorem. That would be my really fast proof if I was able to do this as a proof. If I'm given that 6 is congruent to 12, let's look at 6 and 12. 6 congruent to 12. Well, if those are congruent, then that would mean that C would be parallel to D. C would be parallel to D by the alternate interior angle theorem, because 6 and 12 are alternate interior angles. And I use the regular version, not the converse, because I'm proving lines to be parallel. Now let's take a look at our next problem. Given 8 is supplementary to 9, well, let's find 8 and 9. Here's 8, here's 9. Those are consecutive interior angles. And if my consecutive interior angles are supplementary, then C and D would be parallel. C would be parallel to D by the consecutive interior angle theorem. And let's look at 16 supplementary to 13. Well, if I've got angle 16, which is right here, supplementary to angle 13, that's right there, those are consecutive exterior angles. And if those are supplementary, then lines A and B are parallel. So I could prove that A would be parallel to B by the consecutive exterior angle theorem. And finally, if I've got line A parallel to B, so A parallel to B, I'm able to prove that 5 is congruent to 13, angle 5 congruent to angle 13. Well, those are corresponding angles, so I'm able to prove that by the converse of the corresponding angles postulate. So really, guys, this just relies on being able to recognize the vocabulary word that associates those two angles and recognizing whether or not it's the converse. So if I'm given the lines parallel, it's always going to be the converse. Whereas if I'm given that the angles are either congruent or supplementary, then it's not going to be the converse. So there we go, guys. I want you all now to go and work on the MML practice for this assignment. Thank you.